Good morning. I hope that you are fine, that you're doing well. Welcome to today's class. Today, we want to try and finish up the syllabus. There is one area that is remaining in our course outline, which is mobile IP and cellular IP. It's normally treated as one area, though when you can see in your course outline, it's actually divided like two topics, but it's kind of the same thing. It's treated as the same thing. So that is what we want to learn today: mobile IP and cellular IP. The first thing that we need to do, if I may share the screen here, the first thing that we probably need to do is to probably define what is an IP. IP, what does IP mean? IP is Internet Protocol. Internet Protocol. And what is a protocol? A protocol is a set of standards that guide how communication happens in a network. A protocol is a communication standard. It is like a set of rules or guidelines that guide how different devices in a network should communicate or send data to one another. That is what an IP is. So when you talk about a protocol, when you talk about internet protocol, we are talking about standards that govern communication over the internet, standards that govern how links open, how resources are shared over the internet, standards that govern basically how communication happens over the internet. So when we talk about mobile IP, we are talking about standards of communication over the internet with the use of mobile phones. In other words, standards that govern how communication in the internet happens when users are using mobile devices. Okay. Now, first thing, the reason why it's called mobile IP is because there is internet protocol. Basically, generally the internet protocol that govern how communication happens over the internet, how resources are shared over the internet, and that includes even desktop PCs, laptops, and such kind of things. But mobile IP basically specifically governs, it is the internet protocol for mobile phones. Okay. Why? Because mobile devices are devices that basically have some kind of mobility or movement. People can move with them, like smartphones and tablets and also laptops, some smaller laptops, which you can move around with easily. Yeah. So mobile means that the user's physical location is not stationary, it's not static. Therefore, there is movement happening, and therefore, what that means is that when you have a mobile phone or a mobile device, there is something called data roaming. Data roaming. Data roaming is basically the ability to stay connected to the network as the user moves. So you are able to actually do whatever you would do as though you were stationary at one point, because basically you have network connectivity wherever you go. And that is why we have what? We have satellites. That is why we have broadcasters. That is why we have routers. That is why we have other communication devices like boosters, or what we call repeaters, telecommunication repeaters. All these kinds of devices, they ensure that even as the user moves around with their mobile device, they are actually able to use the network and they are able to roam. So there is that concept called data roaming. Data roaming is basically the ability to share or to send and receive data through your mobile phone over the internet or over a network on the go or in the move. As you move around, you are able to access the internet. As you are in the car, you're able to access the internet. As you move around, you're able to share files, right? So that is called data roaming, okay? So of course, if a user moves to a region where there is no stable connectivity or there is no connectivity at all, of course, it is going to show at that area of your mobile phone that shows you if you have network or not. Yeah, there are normally some bars some bars that show if you have network or not. So if you are in an area where there is no communication or there is no connectivity, sorry, then of course data roaming will not be possible. All right. So again, I've said that mobile IP is basically it is an overall way of describing how data roaming happens. Okay, how data roaming happens, and why we use the word data roaming, because basically data roaming is sharing data or sending and receiving data on the go or in the move as you move around. So mobile IP is basically all those standards, rules and guidelines that guide how communication happens, in on the go as the user is using a mobile device. Okay, so there are different things that you need to there are other things that you need to know. The first thing that you need to know is how to make the network for mobile phones reliable. How do you make data roaming possible? Because remember, the approach needs to accommodate movement, because it's not a stationary phone. I mean, it's not a stationary device. The approach therefore needs to accommodate movement or the possibility of movement. So there's an approach that is used. There are two approaches that are used to ensure that the reliability is achieved. And this particular approach consists of two addresses: the home address and the core of address, COA, core of address. Home address is permanent and it associates the host to its home network. All right. The home address is basically an address is basically it's like a key. All right, a key field. All right. A home address is basically a permanent address that associates the host to its home network. The host is basically the particular devices that support the mobile phones or the mobile devices in that network, right? So there is what we call the home address. Okay. So for instance, Safaricom as a telecommunications company, they are going to have their repeaters, or what we call their boosters. Okay. And therefore, all the devices that manage communication within their territories, they are recognized by what we call a home address. All right. So a home address is permanent. It never changes. Okay. It never changes. And therefore, it associates the host to its home network. Then there is the core of address. The core of address. It's called the core of address, COA. Right. The care of address, not core, but the care of address. Care of address, COA, care of address. Now the COA is a temporary address which changes when a host moves from one network to another. The care of address changes and is associated with foreign networks to which the host moves. So the home address is a permanent address that associates the host to the home network. Like Safaricom being a telecommunications company, they have their repeaters, right? Their devices. All those devices that support communication within their territories, they are recognized by a home address that never changes. And then the care of address is basically a temporary address for mobile phones, which changes as the host moves from one network to another. Okay, so for instance, look at this diagram here, where we have this particular address 133.16.124.8. I believe that you have done something to do with computer networking. So when we talk about IP addresses, that's what we're talking about, mobile IP. So when we are talking about IP addresses, you know what we are talking about, yeah? An address, an IP address is basically a signature or an address, just a unique address. It's a unique identification, yeah, that identifies a device that is communicating in a network. Okay, so this would be permanent address. And for instance, if you install a Wi-Fi, a router, you know, that router will have its own address. If you install a switch, that switch will have its own permanent address. It doesn't change, okay? But for things like the mobile phone itself, the mobile phone's IP address may change, okay? It may change. You can also assign a different IP address. There is what we call packet tracer. There is a software called Packet Tracer. You can actually see how IP addresses are shifting or being modified as the network expands. Okay. I think these are things you've already done in networking at some point. So IP addresses, you have the IP addresses. So you have generally the internet, right? The internet, and then you have another different mobile phone. So let's say this is a mobile phone. Of course, this is not a very perfect drawing because this shows a computer desktop PC. But let's talk about this being a mobile phone and this being a mobile phone. So this mobile phone is in a different network from this one. Okay, this one and this one, they are in different network. So this one is in a foreign network, this is in a home network. This home network has its own IP address, okay? IP address, set of IP addresses. But this foreign network also has its own set of IP addresses. So for these devices that have their own unique set of IP addresses in different networks, how do they communicate? They communicate through what we call the foreign agent, okay? And that's what we are going to look at. What is the foreign agent? Now let's go and now discuss the home agent and the foreign agent and what are these terms as relates to mobile IP. Home agent is a forwarding mechanism which keeps track of where the mobile host currently is in the network. Then it acts on behalf of the mobile host when a remote host sends a packet to the mobile host. The home agent receives the packet and sends it to the foreign agent. So home agent is basically, home agent is basically a mechanism. It is like a networking algorithm, a way of doing things. An algorithm is a way of doing things. So a home agent is like an algorithm, a networking algorithm, which basically does one thing. It keeps track of where a mobile phone is, okay? It keeps track of where a mobile phone is. And it also acts on behalf of the mobile host. So when the mobile phone sends a data packet, okay, it is the home agent that receives the data packet and then sends it to the foreign agent. The foreign agent now, let's see now what it is, and then now we're going to wrap all that up to say how the home agent and the foreign agent work together. So now the foreign agent is the one when the home agent picks an address from a mobile host that is in a home network. A home network is just a network that has basically its own set of IP addresses that are unique than another network. Okay, and it's called a home network because it is where those particular mobile phones that we are talking about that are sending data packets are or residing. Okay, so if we are, for instance, if I'm in my house and other people are in my house, or in the apartment where I live, there is Wi-Fi there. So of course, what we have there is basically, we can actually call that a home network. It's basically a kind of a local area network, a wide area network, because we're able to access the internet and the foreign networks. But we are a home network because we use particular sets of IP addresses. Okay, sets of IP addresses that are unique to that particular network or to that particular Wi-Fi connection. So the home network, basically, when we are sending data with our mobile phones, we are data roaming, we are accessing sites, we are providing details, we are typing this, typing that, we are providing details, we are sharing pictures and all those things, sharing videos. Basically, we need to have a way in which all that we are sending out to other networks, like in the case of the internet, to normally interact with people and mobile phones and devices that are in other foreign networks, right? So you have to have a mechanism to send all that data to other networks. So what sends data to other networks using mobile phones or data roaming is called a home agent. It is a data roaming algorithm that supports mobile networks. All right. What it does is that it picks data packets. A data packet is basically a set of data and its instructions. What that data does when it goes to the network, it's called a data packet. A data packet normally has data bits or bytes, and then it has data address, a unique address that identifies that data packet, that also contains the destination address where that data is going. So if I send someone something through email, that data packet has the recipient's address, not the one that I enter. The data packet itself has a recipient's address, a logical recipient's address that the home agent will see, okay, and determine where that data packet should be going. So the home agent basically picks the data packets from a mobile network, from a home network, sends those packets to the foreign agent of another network. So the foreign agent now picks those packets from a home network, then sends it away from home. Now, what we are calling home here, home is just basically what? Home is basically the original place where those data packets are coming from, all right? So it sends them from home, and then now does what? It receives and delivers packets sent by the home agent, that's what we are saying, to the mobile hosts that are in a foreign network. Okay, so that foreign agent is specifically, just as a home agent is a mechanism, right? It can be a physical or a logical mechanism. It can be an algorithm or a device. An algorithm, a way of doing things. A device, it can be a router. A foreign agent also can be an algorithm or a device. And if it's a device, we are talking about a router, because we use routers and routers and gateways to implement a wide area network. You remember those networking devices. So a foreign agent can be a router whose work is basically to pick all that and send them to the mobile phones that are in another network. Okay. Now that foreign agent, if it's a router, it maintains now what we call a care of address. So we've talked about a home address and care of address, right? So there are two addresses associated with mobile IP. Home address and care of address. Home address is the addresses of devices that are in a particular permanent network, right? And then the care of address is basically maintained by the foreign agent. Packets for the mobile host's home address are intercepted by the home agent and then turned to the foreign agent, what we have just said before. Then foreign agent forwards the packets, what we just said, to the mobile host for which it is providing services. So home network, all the devices in a home network are recognized by a home address. All the devices in a foreign network are recognized by a care of address. All the devices in a home network can do data roaming because they are facilitated by a home agent. It can be an algorithm or a router, okay, that picks data packets and sends them to other networks. Then all devices in a foreign network are facilitated, or they receive data packets from other networks to its network by a foreign agent. Okay, so basically it's like here we have a router, another person has a router somewhere, another person has a router somewhere, all those devices. Now, because I'm the one who's sending data for packets, I will consider myself to be in a home network, right? And the other people are in foreign networks. And then another person who's using a network, they consider themselves as to be in a home network. And then they consider me and others to be in foreign networks. Okay. So basically, we call that device, whether it's a router or a gateway, those devices that enable us to access the internet or to implement a wide area network. Those devices, we call them home or foreign relative to who, all right? Relative to who is using them. Because for me, in the network that I'm using, I'm in a home network. Other people are in foreign networks. Another person, they are in, for them, they consider themselves to be in a home network. And me and others, okay? each of us is using a particular device, a router and gateway, such kind of things. Okay. Right. So how does the mobile IP work? How does this mechanism, the standards that enable and facilitate data roaming with mobile devices, how does it work? First of all, this protocol, it routes packets from a source to destination by using a routing table, right? It routes packets from a source to destination. A source is one mobile phone, destination is another mobile phone, right? Or device to device. It routes. Routing is basically determining the best possible path, determining a route. Okay, so it routes packets from a source to destination by using the concept of routing table. Now, what is a routing table? A routing table is basically a logical database within a router, inside a router, and not inside. Inside sounds like physical, right? But implemented by a router, a logical database implemented by a router that basically contains the following information: the devices that roam data packets through it, okay, or the devices it supports, and also the particular paths. Yeah, paths are basically frequencies, paths that are used for data communication by those mobile devices it facilitates. So a routing table maintains basically the information for destination. So that routing table contains the names of devices. They are not the names, but the IP addresses of the devices, and also what? The IP addresses of the devices, and also the paths of communication they frequently use. Okay, so it's going to be choosing one of those paths. For instance, if I type something on Google and I press enter or I press search, it is the work of the router to determine the best possible path that data packet is going to go out, and the best possible path that incoming packets will use to come to my mobile phone until I see it on my screen. Okay, so that's how mobile IP, that's how the first thing, the IP routes data packets to the router, okay, or through the router. The router does that by using a routing table. The routing table normally has the information about the IP addresses of the mobile phones it facilitates and the best possible paths for data to roam from the network to foreign networks and from foreign networks to the home network. Okay. Then what next? What happens next? Then the home agent redirects packets. The home agent is basically that router. Okay, it can be a device or a router, a device or an algorithm. So if it is a router, the home agent is that router. So the home agent now redirects the packets, okay, from the home network to the care of address by constructing a new IP header that contains the mobile host's care of address as the destination IP address. Basically, simply what this means is that that particular router will redirect the packets, the data packets coming from the home network to the care of address or to the foreign agent, okay? And then the foreign agent uses a care of address, okay? That's basically what that means, because we have already discussed the foreign agent and the home address and the care of address. Okay. Then all the packets that are being sent from a home network have to be encapsulated. And being encapsulated is basically binding them together to recognize them as packets sent from a particular network. Okay, so all data packets have to be encapsulated, all right? And this encapsulation is called tunneling, okay? Tunneling. So if you are in your house or in your apartment and you have a Wi-Fi, that Wi-Fi implements a home network. It basically implements or creates a kind of a network, a home network, right? And that network, whenever all of you guys are using the Wi-Fi to access the internet, all your data packets that are going out from that network into the internet to other networks, yeah, basically what that Wi-Fi does, that Wi-Fi is the home agent, okay? And that Wi-Fi, what it does, it encapsulates all that data you people are sending out, data packets, and recognizes them as data packets from my home network. Okay, so that kind of encapsulation is called tunneling. Why is tunneling important? It recognizes data packets as coming from one particular network. So it's for identity. Tunneling is for identity purposes. Okay, and also when it treats data packets in form of capsules, from the word encapsulation, capsules. When it treats data packets in form of capsules, it is able to do more with less bandwidth. Okay, it is able to do more. The router is able to do more with less bandwidth. So instead of treating every data packet I send from my mobile phone and another person sends from a mobile phone like single data packets, it treats all those packets like one using minimal bandwidth. All right, so that's the advantage. Okay, so the mobile IP therefore is based on the following mechanisms. Number one, routing. Okay, routing of the data packets. Number two, encapsulation of the data packets. All right. Number three, identifying the foreign agent. Number four, assigning a care of address. All right, assigning a care of address. So those are the mechanisms for mobile IP. Okay, mechanisms for mobile IP. Number one, routing. It uses a routing table, right? Number two, encapsulation. Before those data packets are redirected to the foreign networks, they have first to be encapsulated, bound up together to be number one, to be recognized. Number two, to treat much data with lesser bandwidth or with minimal bandwidth, hence bandwidth efficiency, right? So number one, routing. Number two, encapsulation. Number three, identifying the foreign agent, and it is the home agent that identifies. So this router identifies another router, right, to which the data packets are going. Okay, yeah. So the identifying a foreign agent, and then after identifying a foreign agent, this foreign agent creates a care of address. Care of address is now the address that is able to link the home network and the foreign network, so that now communication can happen. So those are the, and then of course, lastly, data packets are received. All right, that's basically that. Are we together? All right, so basically I've just summarized all this. Okay, I've summarized these three into five. I've given you five strong and narrative points because I deem these ones to be brief and they do not really discuss this particular info here. So this info here, how mobile IP works: number one, routing using a routing table. Number two, encapsulation. All those data packets are bound up as one, treated as one, and we see the advantages. Number three, a foreign agent is identified, right? And then a care of address is created by the foreign agent so that it can link up then with the IP address of the home network. And then when a care of addresses are formed, then those data packets are routed and redirected to the device, to the foreign agent. It is the foreign agent that therefore delivers those data packets to the recipients, okay, to the mobile phones in that network that are recipients of the data packets. So that's basically it, right? So I've just summarized all this data transfer and all that, okay? Now there are some disadvantages of mobile IP. There are first advantages of mobile IP. The first advantage is that data can be sent on the go, all right? Movement, data roaming, it's an advantage. You don't have to be stationary at a point like connected to an Ethernet cable like a desktop PC. Or yeah, you don't have to really do that. You can roam because there are support devices that can enable you to roam, like repeaters, routers, yeah, such kind of things, telecommunication device, even satellites, yeah. So that is one advantage, data roaming, all right? And it's the strongest advantage, basically. It's the strongest advantage. But one of the disadvantages here of mobile IP, there is also the issue of security. There is a disadvantage of security because we have what we call cyber crime, cyber security, right? Cyber security, where your information through a network can be tapped. It can be tapped. There are professional people that can do that, right? They can tap data going through a network. They can decrypt. They can tap it, right? They can kind of eavesdrop. You remember the internet security crimes or breaches? Hacking, cracking, phishing and farming, eavesdropping, tapping, sabotage, fraud, right? So there is that particular, but most telecommunication devices, of course, ensure that their mobile phone users are secure. Because when was the last time that you had some people complaining through that they did not feel secure using Safaricom or Airtel or Telcom or Orange? When was the last time? I mean, it doesn't really occur, but if it is a possibility, okay, it is a possibility. Also, there is sometimes when you go to areas when there is no network connectivity. So there is that particular disadvantage that there are areas that are uncovered. You cannot really do a lot of communication in those areas. Like most of you, when you go to your rural homes, you realize probably sometimes some of you may not be able to enjoy the internet as you do when you are around the suburbs of town or in town. Okay, yeah. So that's a disadvantage of sometimes there is no network connectivity in some areas. Okay. And what if some devices crash, right? What if some devices crash? Support devices like these home agents and the foreign agents, the routers. What if they malfunction? So that means your communication will be incapacitated, right? Your communication will be sabotaged, will be made impossible because of such support devices. What if in a particular cell the repeater that is there or the antenna malfunctions? What does that mean to all of us that are within that cell? We cannot call out and we cannot receive calls, right? So you see, there are those, yeah. And again, but of course, these are rare kind of occasions. Of course, the advantages outweigh the disadvantages. Okay. So we have discussed the mobile IP. Okay. Now, because of there is one particular disadvantage of mobile IP, and one particular disadvantage apart from the ones we've talked about. There's one particular disadvantage where the mobile IP can fail to update an address properly when for high-speed mobility. For instance, imagine if you're in a, of course they don't allow it, but if you're high up in a plane and you are surfing the internet, right? Of course, normally they don't encourage, because of course those kinds of waves, they normally disrupt the waves that's there. That's basically that's the I'm trying to find words for this. The radar systems, the ones that actually they keep in communication. The pilots can keep in communication with people on the ground or at the airports. So while they are up there, they can actually keep some kind of communications. That's why they normally discourage passengers from having their phones on. But that doesn't mean that you cannot put it on, because can you imagine flying 8 hours and your phone is not on? It normally doesn't really work that way. People do, put on their phones and they're able to surf the internet and all that. So can you imagine when you are in an aeroplane, it's moving at a fast speed. So meaning that data roaming here is going to take another different trajectory, because you are moving at a fast speed. Therefore, meaning that you are moving from one cell or from one network to another very, very fast, right? Because you're in an aeroplane. So when there is this called high-speed mobility, where the mobile phone tends to be changing location very, very fast, or at very fast intervals, then there will be a challenge in updating the addresses, okay? Updating the address of each particular network it enters. In updating the address of that mobile phone, the IP address of that mobile phone into every network it enters into, all right? So that challenge will therefore be addressed by what we now call cellular IP, okay? Cellular IP is basically a new host mobility protocol that is designed to address this issue, all right? This issue of where mobile phones are moving from one network to another at very fast speeds, e.g. if you are flying on a plane, okay? The addressing may not be very, you see, if I'm seated here, where I'm seated right now as I'm teaching, I'm using a router, okay? There's a router, and you know, it's stationary, I'm not moving, okay? So data roaming is very, very easy, because the data, the router is basically just picking my address, picking my data packets, directing them to foreign networks, right? Such kind of things. But what if I'm moving from one, you know, from one place to another on a plane, right? One place to another on a plane. You'll realize that I'll be moving from one network to another, and therefore mobile IP, sorry, something happening. Mobile IP doesn't address that particular issue of how do we give mobile phones communications addresses when they are really moving or changing from one network to another, but because you well know that an address has to be consistent to the network that mobile phone is in, right? So if that mobile phone keeps changing at very fast speeds, then mobile IP may not keep up or support data roaming in that case. So cellular IP is therefore the approach, all right, that is designed to address this issue of addressing. Okay, so we have less than 1 minute remaining. Let me create a session. So that we can continue immediately after the class. This session is over, right? So that we can continue.